let's go ahead and create the sewer network, but first we need to set up the GIS for importing. I like to have a different CAD layer for each aspect of my sewer model, and let's have a look at that. So if we add with the GIS, we'll call it GIS SE for the sewer, and then we'll call this the pipes. I'll do one for the pipe diameters as well. Manholes invert level, or invert levels plural. We also need a CAD of the sewer outfall, so that when it's modeling it knows where to drain the sewage towards. This is something that we do manually, and we're going to attempt to bring this information from GIS in. There might be a few pieces of information missing, and I'll try and explain how to handle that and how we'll do it in this model. I'm going to switch off the cadastral boundaries for now. I don't need that information. And I'm going to bring in the pipes. So let's make the sewer pipes the current layer for now. And we'll just go to CAD mode, and then we'll go say File, Load, Drawing. We'll change that to Shapefiles, and we'll bring in the sewer pipes. Would like to bring in some other information, so I'm going to choose to also bring through the nominal diameter as text, and 3 millimeters in height is fine. You'll notice over here that it's brought in the text as well. So what I'm going to do is I'm going to press escape once, select one of the text, and then I will select the same type. With the same type selected, I'm going to go and use the properties like a filter and change that to the pipe diameter. So the text is now sitting in the pipe diameter for the GIS sewer. We need to bring in the invert levels, so let's bring that through. Let's change this to invert levels. We can go to File, Load, Drawing. We'll then load in the shapefile, and we'll bring in the sewer manholes. We don't need to bring in the physical manholes. I'm more interested in the information about the manholes, because Civil Designer will see 2 CAD lines terminating, and it'll know it needs to draw a manhole there anyway. So we'll want to bring in the invert levels, and that is stored in, it's brought through points and text. I'm not too sure about the points. We probably want to delete that, and it's brought in the text as well, and that's sitting in the layer called manholes. Let's just quickly see if we can isolate those points, those CAD points. I'm going to do a box selection, so everything inside this box will be selected. There I can see I've selected the point. I'm going to use holding down the shift key and use a crossing selection to deselect the text, and now I'm left with the point, and in the properties you can see I've selected the point. I'm going to right click and go to select same type, selected all 17 points, CAD points, and I'm going to delete that, pressing the delete key on the keyboard. I really don't need that information. The invert levels are in meters above sea level. However, this type of accuracy is never needed. You wouldn't even be able to construct at this accuracy. So I'm not too sure what the GIS department was thinking with having that. But I'm just glad that we've got some invert levels, because I found that a lot of the time Z values don't get stored with in the GIS departments. You'll notice that there's some information missing here. It's more than likely that the pipe is actually longer than this piece because it's cutting off on the edge of this DTM on this side as well, and over here. If you are going to put in levels that are missing, it's best to go and get that level surveyed and put in. We don't know where this pipe is, and that won't form part of this video, so we'll just cut it off. You would need to find out where this pipe is in a real world project, because it is contributing to your flows. So you would need to actually go and find more information on these pipes and get those invert levels surveyed by a survey professional. I'm just going to remove them for now, and you can see this pipe is ending off the DTM here. You would need to get more information for the DTM. For now, I'm not too worried. You can also notice that all the pipes are 160 diameter, so we can actually just set up the pipe diameters in the default settings, which I'll show you in a moment. We're not really worried. Here I'm going to actually take off this pipe, and I'm going to terminate at this location, and I'm going to terminate at this location here. It's always a bit worrying if it's going off the DTM. You'll see if I put the triangles on, it's right on the edge there. So what we can do is just move it up. I'll just put it over here. You can't do this in the real world. You actually need to go and get it surveyed in a real project. Great. Now what we need to do is create the outfalls. Remember, this is a manual process just to show the computer where the lowest outlet is on your project. And in CAD mode, I can go to draw, circle, and I'll do center with a radius. So there I can do a 1 meter radius, press the green tick, and well, that's a 1 meter diameter. That's fine. And I'd like to snap to the end here. Okay. Let's just press J and enter. So let's put it in there at the end of this CAD line. I'll come back and check it in a moment, and I'll press J and enter here. Here you can see it's on the center or on the edge of the line, and here it's on this edge of this line here. Great, and those are both sitting in the layer called CAD outfall. And I don't have an invert level for this line over here, so we would need to actually get a invert level surveyed and placed in here if we want to be accurate. For now, what I'm going to do is I'm going to go and copy this base point, press J enter, and I'll paste it over here, J enter, and we'll make it 39.5. Great. We can now import this into our project, so we can go to sewer mode, and we can go to file, project settings. We need to create a database to store it in. I'll click on the tick, we'll go inside here, and we'll call this civil project sewer. We can save our work so far, and we can then import it. Before we import it, remember we spoke about the 160s all being 160s, so you can convert using the layers, or you can go to your default settings, which is edit default settings, and you can change all your pipe types or diameters to be 160. Auto sizing means it will choose a pipe size for you based on capacities, but you can fix it. In our case, we are modeling an existing network, so we could choose the 160s and say okay. We can then bring in the node names if you wish. Let's go and have a look at what those look like, if there's anything of use there. So we can go and right click here. We can add an extra layer called GIS SE manhole names. We can make it the current so that it'll update there. And let's go and see if we can bring in those. So I'm going to go to load drawing, change that to shapefiles, select the manholes, object ID. Let's have a look at what that looks like. Okay, the object ID is quite long. If you want to work with that, that's fine. Let's see if we can work with that. So I can now go into sewer mode and we can go to our default settings under edit. We can change those pipes to 160. We can then change the pipe diameters to 160 and we can say OK. So that when it converts, it will convert to 160 unless otherwise stated in the CAD layer. So here you've got 160 stated in the CAD layer. You could make this a 200 if you wished. Let's change this one to be a 200 diameter in the CAD and see if that comes through. I'll now in sewer mode convert these. So I'm going to go to import, convert drawing entities. And I'm going to go to the sewer outfall, and that's going to be sewer outfall, node names, the manhole names, invert levels, the invert levels, pipes itself is going to be the pipes, and the diameters is going to be the pipe diameters. Let's have a look at that again. Outfall, no, names, invert levels, links, pipes, diameters, diameter. Perfect. Great, with it converted into a network, let's just see if everything has come through. So I'm going to go to my display settings. I'm going to go to my link data. Let's put on the size of pipe in millimeters, and under the nodes I'm going to put the manhole name, and for now I'm going to use the invert level, just have that displayed. That's in meters. Just put the invert level. Let's have a look. So it looks like the invert levels have come through. It does round it. You'll see there, it doesn't bring in the whole thing. And that's because we don't work to that sort of level of accuracy ever. You'll never be able to get any contractor to construct in that level of accuracy anyway. It's brought through the names. You'll notice the manholes that don't have names get assigned a name. Let's have a look at that diameter. Here you can see 160 is the default, but when we've chosen a different diameter from the defaults, it has picked up and used that other default. One important thing to just take note of when dealing with importing, whether you're importing through using the CAD, is that the CAD needs to match up with your link table. So if we go to edit and we go to link types, if we're using the UPVC, then if you go to your sizes, here are the sizes that need to be shown up in the CAD as well. You can't use any CAD that won't correspond to the nominal diameters. I hope that was insightful. As you can see from this, there's no gold standard when it comes to using GIS data, and that's why it's important to always bring the GIS data into a CAD so that you can really thoroughly investigate it and see what you're actually dealing with, and then convert it to either the DTM or the sewer, stormwater or water networks.